Let's discuss valency. So this refers to the number of electrons that an atom loses or gains during a chemical reaction. Now, when it comes to atoms, most are unstable, and in order to attain stability, they either lose or gain electrons. So the number of these electrons that are lost or gained refers to the valency. Okay, to make this clear, let me use the example of the group 1 metals. I'm talking about lithium, sodium, and potassium. All of these three have one valence electron. This is the electron that is present in their outermost energy level. Now, during chemical reactions, they lose their valence electron. Therefore, they have a valency of 1. What about the group 2 metals? This is beryllium, magnesium, and calcium. These have 2 valence electrons. Therefore, during chemical reactions, they lose both and thus have a valency of 2. Now, it's very easy for you to determine the valency of the first 20 elements. All you need to do is write down the 20 elements in order. Now, I have a mnemonic for you that will make this very easy for you to remember the arrangement of the elements in order, starting from hydrogen to calcium. So let's start. Hi, hello, listen to BBC News on Friday night. Some men are selling pizza, so contact Argon Pizza Company. And there you have it, your first 20 elements in order, arranged according to the increasing atomic number. So in short, this simply means that the elements are arranged according to the number of protons that they have, starting with hydrogen that has 1 proton and calcium that has 20 protons. Now, once you've done this, your next step, of course, is going to be placing the electrons in their respective energy levels. Now, I want to remind you this, in an atom, if you have a particular number of protons, then the number of electrons is going to be equal to that. So if you have an element that has 1 proton, such as in the case of hydrogen, it's going to end up having 1 electron. If it has 2 protons, 2 electrons, and as such up to calcium, where you're going to end up having 20 electrons. So let's place these electrons in their respective energy levels. Bear in mind that the first energy level can only take a maximum of 2 electrons. Any other electrons will be pushed to the next energy level. Now, energy level 2 and 3 can take a maximum of 8. Let's look at lithium. Lithium has 3 electrons. So we're going to put 2 in the first energy level. 1 will carry forward to the next energy level. So it's going to have an electron configuration of 2, 1. So we're going to continue with beryllium 2, 2 up to neon 2, 8. Now, when it comes to sodium, sodium has 11 electrons. So 2 in the first energy level, 8 in the second energy level, and those energy levels are now full. They cannot take any more electrons. So the remaining 1 electron will have to be moved to the third energy level. Okay, let's continue with magnesium 282 up to argon 288. Now, when it comes to potassium, potassium has 19 electrons. So that is 2 in the first, 8 in the second, 8 in the third, and the remaining 1 will be moved to the fourth energy level, and same with calcium, such that we end up having 2882 as the electron configuration of the calcium atom. Now, once you've done this, you are now ready to determine the valency. Now, I'm going to give you a very easy way for you to do so. So we're going to group the elements into metals and non-metals. So for example, the metals in this list are lithium, beryllium, boron. Okay, boron is a metalloid, but let's just place it in the metals. We have sodium, magnesium, aluminium, potassium, and calcium. Now, when it comes to the metals, the number of valence electrons is equal to the valency of that atom. So if we have lithium having 1 valence electron, that means its valency is also 1. Beryllium has 2 valence electrons, therefore has a valency of 2. Boron, 3, a valency of 3. So in the case of metals, the number of valence electrons equals its valency. Now, for the non-metals, what you're going to do is you're going to take the number of valence electrons that they have, subtract it from 8. So for example, in the case of carbon, carbon has 4 valence electrons. So if we were to take 8 minus 4, we end up having a valency of 4. So the valency of carbon is 4. Nitrogen has 5 valence electrons. So 8 minus 5 gives us 3 as its valency. Oxygen has 6. So 8 minus 6 gives us 2. So the valency of oxygen is 2. Fluorine has 7. So 8 minus 7 gives us 1. Now, there are two exceptions to this rule. Number one has to do with hydrogen. Now, even though hydrogen is a non-metal, we are not going to subtract 1 from 8. We're just going to leave it at that. So the valency of hydrogen is 1. Now, the other exception to the rule has to do with noble gases. These are the members of group 8, helium, neon, and argon. Now, these have atoms that have full energy levels. As you can clearly see, helium has an electron configuration of 2. That means the first energy level is full, while the rest have energy levels of 8. So they have full energy levels in short. Now, if you have an atom that has full energy levels, that is a stable atom. So it's unreactive. It doesn't take part in chemical reactions. It's inert. So these have a valency of 0. See how easy it is? Now, I want you to do this. Get a piece of paper and pen, write this down, memorize it, so that next time when you have a question that asks you of a valency of a particular element, you have it down.